challenge question. Today is 29th of January 2023 and the question name is LFU cache. So it is asking us to design a LFU cache, that is least frequently used cache, which is basically used in operating systems, and as it is a cache, so it will be very near to the CPU so that we can access it as fast as we can and do not rely on main memory as much. So to design this cache we need to get it as fast as possible because we need less CPU times to access the data. So for that purpose we are using a linked list. Our structure will be like there will be a linked list. Suppose this is the frequency number, and after that we will have the LRU cache because they are asking to return LRU data, or just remove the least recently used cache entry which is not needed afterwards. So if this is the frequency and these are the list, and here we have data something like 1 2 4, and here I have 4 5 6. So if the size is 6 for this cache and I want to add more data to it, then this is the least frequency, so that is least frequently used, and this will be the least recently used because we will be adding all the recent usages to the head of the linked list. So in this way we are going to work. So let's get started by coding our first class, which is the class node. By the way, we are using the W linked list, and for W linked list we will just be creating our own because we do not want to rely on any other's linked list implementation. So there will be the next pointer, there will be a previous pointer, and here will be the frequency, the key, and the value. Okay, after that, as this is public, I can create a constructor and I can just name it as node because it's the same as class name, and my key will be equal to k, my value will be equal to value, and my frequency equal to 1 because it's the first thing that I am adding to it. The semicolon is necessary here, and after that we will implement a class called as list, which is basically a W linked list. To implement this class we will just go ahead and type something like this and keep everything public, such as node star head, node star tail, size, that's it. And we will also need a constructor here which will be the empty constructor, and the size will be 0. The head will be pointing to nothing, which is just a node which is not of any use, and I am writing key and value as -1 because -1 won't be present according to the constraints of the problem. So after that, if I just add a tail to it with a new node -1 -1, okay, so that's it that we want. And yeah, we just have to point it something like this. Heads next will be tail, and tails previous will be head. So these are the next and previous pointers that were pointing to each other. Now I will create a function to insert a node in the linked list. So if a node came as an input, that is node, the parameter, then what we are essentially gonna do is heads next must be equal to node. Okay, and let's do one thing, just point the nodes previous to the head. So nodes previous equal to head, and nodes next will be head next, and we will create head next. Head next equal to heads next. Okay, and it will be node. So node head next equal to heads next. So nodes previous equal to head, and nodes next will be equal to head next. So heads next will be node, and head next previous will be node. Okay, so we were having this thing and we just got the next element of the node. and just pointed it to it. So if we are having this -1 as our head, it was pointing to suppose 2, and I want to insert one more element into it. So I just introduced that element like this. It was 3, and I want to insert, so I pointed this 3 to this 1. Okay, I pointed this 3 to this 1, something like this, and then I just pointed the heads next will be this. So heads next is this, nodes previous is pointed to head, nodes next was pointing to this 2. Okay, so it was pointing to this 2 in this way, heads next, and heads next. So the head pointers next, which is this particular thing, it will point to node. So this will be like this, it's pointing to node, and this is head next. So its previous was pointing to head, now it will be pointing to node. Yeah, that's it. So the linked list is created. Okay, now we just want to increase the size, and after that I'll just go down and create a function to delete a node. So delete a node star node. If I want to delete a node, I pass the node, then I just need node star previous, which is equal to nodes previous, and node star next, which is equal to nodes next. And as I have both the things, I can just point it like that. So previous next will be next, and next previous will be previous. That's size minus. Okay, so this is what we wanted to code for just a part of the linked list. And now we are going in our function, and we will be creating our very necessary LFU cache. So it's a private part of the C code, and it will be the size, the frequency, which will be the minimum frequency, I should say. So minimum frequency. After that I will just need one more thing called as capacity. So it's the capacity, and then unordered map having the integer, and then it will be pointing to a node. So this will save the key and node as the value. Okay, so key and node as value. Okay, so it will be called as key to node, or I should say, no, it's good name. So I will say unordered a map of integer, and here I will say list star, because I want to create a frequency list map. So here I will have all my lists. Yeah, after that here will be frequency as key and list as value. Okay, now I got this. So size will be 0 in the constructor. Minimum frequency, I've got it. No, I've not got it, but still I have to add the minimum frequency, and it will be equal to 0. And this dot capacity, or this points to capacity, will be capacity. And after that, what I will do, I'll just code this get function. So as they are saying, it gets the value of the key if the key exists in the cache, otherwise it returns -1. So if it not exists in the cache, then it turns the -1. How can we check if it not exists? We have this particular thing. So let's copy this keynode and just go, and now we will just check if keynode dot find the key, and if it's equal to the n, then return the -1. Okay, but if we have the key, then it will be node star node, which will be equal to soft key. So I got the node, I need the value equal to nodes value. So I got the node, I got the value, I just want to return the value. Okay, but here's a catch. We just used the particular node to get it, and as we used it, it becomes the most frequently used, I would say, and not any of the other counterpart of frequently used. So what I would essentially do is I would update list for this particular node. Okay, and we will be creating this function afterwards. Let's go to the next function, which is put. So the capacity can be 0, and if it's 0, we can't put the node. Okay, so if capacity equals to 0, just return it. We don't want to do anything for it. And then if we want to insert the node, if the size is permitting us to insert, and we are doing that thing only here, but they are also saying to update if the key is already existing. So if keynode dot find the given key is not equal to keynode dot end, then what we will do is just take that node. Okay, so it's node star node, which will be equal to this and the key, and then its value will be updated to something else, which is the value given, and then we will just update the list. Okay, but what if it does not exist? If it does not exist, then we have two cases. The list is the capacity of the cache is full, or it's not. So if the capacity of cache is full, I just introduced a bug. So if it's full, then the list that I'm taking will be, but I can't name this as a list, or I can, yeah, I can. It will be lists of the mean frequency. Okay, and for that mean frequency, what I will do, I'll just delete the node. Okay, so first of all, I'll keynode erase the entry from the keynode for the list tails previous key. Okay. And then I'll just list delete node, and the node will be nothing but list tails previous. Okay, and then no, not a wait list. Then I will do size minus minus. Okay, but we can reduce this particular thing to something like tail equal to list tail node equal to tails previous. So this will just be node, this will replace previous, so it will be node. Okay, nice and easy. So I reduced the size, but this will only execute if the size is equals to capacity. But if it's not equal to capacity, or even if we reduce the size, then we have to add the node to the list. So what I will do, I will just increment the size. Okay, no matter this execute or not, I just want to increment the size. So I'll increment the size, and then I'll set mean frequency to 1, because we are essentially adding the element for the first time, and as we are adding it for the first time, the element will be added to the first frequency list, and that's it, because we have already used this. So after that we have the mean frequency, and I'll just take the list, and if lists dot find mean frequency is equal to lists dot end, then list will be equal to new list, which does not take any parameter. else list will be equal to lists and min frequency. So we got the list, we just want to insert a value to it. How we are going to do that? Node star node equal to new node. New node will be taking what? Key value, not the frequency. After that I'll just list and insert what? Node. I just misspelled here. List node. After inserting the node, I want to add that node to the key node. Okay, so key node dot key nodes key will be equal to node. So this is not the case of update, it's case of insertion. And for the case of insertion, I'll just do this lists of min frequency equal to list. So why this will be there? Because we are handling here the capacity and then incrementing the size and adding it if it's the first element, and it's essentially will be the first element only. We are having this particular thing and we are just reassigning it here because we are handling it in this if and else case. Therefore this will work. It's not replacing the list, but in a normal way we can say that it's replacing the list. So now just create this function and it will be the private function for sure. So it will be void update list taking node. We want to update list, we want to remove it. Okay, we want to remove the node. So keynode dot erase. What I want to erase? Whatever has the key as nodes key, and then I want to just get the frequency list and erase the node from there. Okay, so it will be nodes frequency and I got the list. So list having nodes frequency, and here I will just delete node having the name node, right? After that, if the nodes frequency say equal to minimum frequency, nodes frequency equal to minimum frequency, and lists of nodes frequency dot size, nodes frequency and its size is equal to 0 because we have removed the node here. Okay, if it's equal to 0 then min frequency will be incremented for sure. After that, list if lists dot find the next frequency, right? Frequency plus 1 is equal to list dot end, then list equal to list else list equal to lists of nodes frequency plus 1. Nodes frequency will be implemented. List in the list we will insert the node. After that, in the list I have inserted the node, and lists of nodes frequency will be assigned to the current updated list. And after that, keynodes key will be equal to the node. Okay, right, the updated node. So this should now work. Let's see, is there any error? Yeah, I misspelled the node. I don't find anything that I've done wrong. Let's see if it works. So on line number 58 lists of node frequency and size. So it's not a function, it's just a variable. It's this one, this particular thing. And update list, I just called it and not passed my node to it. Here I misspelled the node. And anywhere else, update list function, no, it's not. It must work. Let's see if it works. Yeah, so let's submit it. Works properly. Nice. Okay, so this was the video. I hope you enjoyed it. You learned everything about the cache from this video. And to know more about the cache, just go to operating systems fundamentals and you can just read the part called as memory or storages, and there you will find more about LFU cache. There are different types of caches, LRU, LFU, and this was the LFU cache including the LRU mechanism. So hope you enjoyed it. Thank you very much.